Welcome. My name is Craig Hawkins. I am a professional developer with a master's degree in computer science from Brown University. I have many years of development and teaching experience, and I'm excited to be your instructor. In this quick start course, you will learn the basics of what JUnit is, how it works, and how you can use JUnit to write and maintain quality code. JUnit is a framework for unit testing. And what is unit testing? The main idea is that for every piece of code you develop, you write tests that verify the proper functioning of the code. Test-driven development is a process where you write the tests first and then write your code to pass the tests. JUnit does not require you to work in this way, but it is a popular development style. Here are some of the key advantages of using JUnit. You don't have to intermingle your test code with your development code. You can keep these completely separate. Also, you don't need to write main methods to run your tests. A huge advantage of JUnit is the growing library of tests you create. You keep your old tests, and they become an important part of the project. As you write new code and new tests, you make sure what you are doing does not break your existing code. The way you do that is you rerun all of your old tests. This is known as regression testing. If you broke something, there is a good chance your existing library of tests will catch it. Let's look at an example of how to use JUnit. Here we have a custom Java class named rectangleUtilities, and it has a method named getArea. How do we show our development team that the method is working correctly? Answer: we write a JUnit test and show that the test passes. So we wrote a corresponding JUnit test class named rectangleUtilities_test and a test method named test_getArea, which tests the behavior of the getArea method. The test annotation right here, that tells JUnit to run this test through its test machinery. Otherwise, JUnit would ignore the method. And this assert equals, that's a JUnit assert. And it's basically saying that in order for this assert to pass, the value on the left-hand side should be equal to the value on the right-hand side. When we run the test class and everything passes, we will get a green bar indicating success. This means all of our tests have passed. There could still be an error in your code, but based on the tests you wrote, JUnit found no errors. But what if your JUnit tests found an error? JUnit will output a red bar indicating failure. JUnit will also give you a helpful error message so you can track down the location and nature of the failure. In that case, you fix your source code and rerun the tests again until you get a green bar, which lets you know all of your tests have passed. So here is the development process in summary. You write tests that strategically test your code. You keep writing and refining your code until all of your tests pass. Then you run your existing library of tests to help ensure you did not break existing code. Now we are ready to get started. I'm excited to be your instructor throughout the course and hope you enjoy the learning process. By the time you are done with this quick start course, you will have developed a fundamental understanding of how JUnit works and how you can use JUnit to write and maintain quality code. If you like this quick start course, please be sure to check out my full-length course on JUnit. Thank you, and let's begin. In this lesson, we are going to study the assert equals and assert not equals methods. First, let's take a look at our imports. This import here allows us to use the test annotation, and this import here allows us to use the assert equals method. And this annotation right here, @test, that's telling JUnit to run this method through its test machinery. If the annotation were not there, JUnit would skip over the method. So we have our test method named myTestMethod, and right here, assert equals, that is a JUnit assert method. And assert equals basically asks a question. Is it true that the value on the left-hand side equals the value on the right-hand side? If so, we will get a green bar indicating a pass condition. Otherwise, we will get a red bar indicating a fail condition. So let's run this. And we can see we got a green bar indicating a pass condition because it is true that 2 equals 2. And we also see that the code was allowed to proceed forward, so this print statement ran. Now let me introduce an error. And this time we get a red bar, and it says, assertion failed error. Expected 2, but was 3. And we can also see that this line of code never reached. This word here was never printed to the console. So let me change this back to a pass condition. And once again, we get a green bar. Now let's look at our next example, JUnit's assert not equals method. Our imports are as before, and assert not equals basically asks a question. Is it true that the value on the left-hand side is not equal to the value on the right-hand side? If so, we will get a green bar indicating a pass condition. Otherwise, we will get a red bar indicating a fail condition. So let's run this. And we get a green bar because it is true that 1 does not equal 2. Now let's look at an application. Here we have a custom Java class named string utilities. There is a set of lowercase vowels, a set of uppercase vowels, and we want to test the vowel count method. So we set up a corresponding JUnit test class named string utilities test. And here is our test method, test vowel count. So we created some various strings, and we want to see if our method right here is behaving as expected. So here's a normal case. There's 2 vowels. So when we call vowel count on this string, we should get back 2. Here, there are no vowels, so we should get 0. And if it's the empty string or the null string, we should also get 0 for the vowel count. So let's run this. And we can see that all of our asserts have passed. We get a green bar indicating a pass condition. And this gives us good confidence that our vowel count method is working properly because we tested normal cases as well as edge cases, and they all passed. In this lesson, we learned how to use the assert equals and assert not equals methods. In this lesson, we are going to study the assert true and assert false methods. First, let's take a look at our imports. This import here allows us to use the test annotation, and this import here allows us to use the assert true method. And assert true essentially asks a question. Is it true that the value inside the parentheses is true or evaluates to true? If so, we will get a green bar indicating a pass condition. Otherwise, we will get a red bar indicating a fail condition. Now here, this is true, so this is going to pass. 2 does equal 2, so that will evaluate to true. So this will pass. And it is true that the length of string ABC is 3, so this will pass as well. Let's run this. And we can see that all of our tests have passed. Now let me introduce an error here. And we can see that tests 1 and 3 passed, but this blue X right here indicates that test 2 did not pass. And we also got a red bar indicating an error. And here is our helpful error message. Expected true, but was false. And it also gives us the line number right here, line 15. Now let's look at our next example, the assert false method. Assert false basically asks a question. Is it true that the value inside the parentheses is false or evaluates to false? If so, we will get a green bar indicating a pass condition. Otherwise, we will get a red bar indicating a fail condition. So this is false, so this will pass. It is false that 1 equals 2, so this will pass. And it is false that the length of string ABC is 4, so this will pass as well. And we can see when we run it, our test method has passed. So here is an application example. We have our string utilities class from before. It has a set of lowercase vowels and a set of uppercase vowels. And here we are interested in testing the functionality of the isCapitalized method. So this is the implementation right here. So we set up a corresponding JUnit test class named string utilities test. And here is our test method. Test is capitalized. And out of these 5 strings, only the first one is capitalized. So this one should return true, and all of the others should return false. Let's run this. And we get a pass condition. And since we tested normal cases as well as edge cases, and everything came back as a pass condition, that gives us a good confidence that we have implemented our method correctly. In this lesson, we studied the assert true and assert false methods. In this lesson, we will get practice fielding a bug report, and in doing so, we will see a customary 4-step bug fixing process using JUnit. So let's take a look at the bug report. The graphics team is getting incorrect results when using the getPerimeter method in the Rectangle Utilities class. Please fix the bug and submit updated code along with a corresponding JUnit test. Thank you, Software Management Team. So here is the bug fix process. First, we create a JUnit test that triggers the bug. You don't fix the bug first. The first thing you do is you create the test that isolates the bug. So you want a fail condition, a red bar, because that shows you isolated the bug. Then you go ahead and fix the bug in the source code. You run your JUnit test again and get a green bar. This indicates that you fixed the bug. And then you submit your updated source code along with your JUnit test or tests to GitHub for code review by your tech lead. So here is the Rectangle Utilities class, and this is the method that has a bug in it, getPerimeter. So we set up a corresponding JUnit test class right here, Rectangle Utilities test, and here is our test method, test getPerimeter. And there's the height and the width, and this is our expected value because perimeter is 2 times the height plus the width. And the actual value is what the method is returning. And that is an important JUnit design pattern. Expected is what you believe the value should be, and actual is the value that your code actually produces. And then we are using the assert equals method. These two should be equal to each other if the code is behaving as we expect it to. So let's run this. And we can see we get a red bar, and we can see this blue X here indicates that this method has failed. And we see we also get a helpful error message here. Expected 20, but was 10. So we go back to our code, the source code, and we say, okay, this is the problem right here. It should be 2 times the height plus width. So we fixed our source code, and now we run the test again. And the test has passed, indicating that we have fixed the bug. And as an important note, as you create bug fixes, these tests become an important part of your testing code base. When your source code is altered or added to, all of your old JUnit tests get run again. This back testing is known as regression testing, and it helps ensure new development efforts are not breaking existing functionality. The library of tests you create become a very valuable part of your project, equal in value perhaps to the source code itself. In this lesson, we practiced using JUnit to field a bug report. In this lesson, we will get practice implementing a feature request. To do so, we will use JUnit and test-driven development. So let's take a look at the feature request. The graphics team wants a method for the Triangle Utilities class that lets them know if the triangle is equilateral. Please implement this method and submit the source code along with a corresponding JUnit test. Thank you, Software Management Team. So here's the process. First, what we do is we create an empty method that does nothing. We write a JUnit test or tests that properly exercise the method. Then we run the tests. The tests are going to fail because the method is not yet implemented properly. And then from that point forward, we write and refine our source code until all of our tests have passed. Then and only then do we submit the source code along with the tests up to GitHub for code review by the tech lead. So here's our class right here, Triangle Utilities, and here is a kind of blank dummy method. It's just going to throw an exception. And here's our test. 2, 3, and 4, these are all different sides, so it should be false that that triangle with sides 2, 3, and 4 is equilateral. And if 2 out of the 3 sides are equal, it should also be false. only when all three sides have equal length should it be true. So let's run this. And we see we get a fail, which is what we want. And we can see unsupported operation exception, not yet implemented. Now what we do is we go ahead and we implement the method. So they should all be equal to each other. Okay, so let's run this. We're still getting an error. Interesting. Okay, let's see. Expected false, but was true. Okay. Line 11. Right there. Okay. Ah, you see? It should be not the OR operator. It should be the AND operator. Now, obviously, I did that intentionally, but I wanted to show you how your test-driven design will help catch errors like that. If you didn't write your tests first and you kind of dashed things off, you might be like, okay, I'm good. But this helped catch things. Now our tests pass because it's not OR, it's AND we need. Side A equals side B, and side B equals side C, and side A equals side C. So that's the process right there. We started with a blank method. We ran our tests, it failed. And we kind of wrote and refined until all of our tests passed. And then we had a good confidence that we wrote it properly. And then we send it off to GitHub for review by our tech lead. And as an important note, like your unit tests for bug fixes, you also save your unit tests for feature requests. These unit tests serve as guards against breaking changes. As you implement new features, you run all of your old tests to make sure your new development efforts are not breaking existing code. So your library of JUnit tests grows alongside your source code base. In this lesson, we practiced using JUnit and test-driven development to implement a feature request. In this lesson, we will study the before all and after all annotations. Methods marked with before all run exactly once prior to the running of the test methods. Methods marked with after all run exactly once after the running of the test methods. Before all and after all are useful when you need to perform setup and teardown work, such as connecting to and disconnecting from a database. Let's look at the details. So this import here allows us to use the before all, after all, and test annotation. And let's run this. And we can see that since this method right here has the before all annotation, it ran first, then the general test methods ran, and then finally this method ran last since it has the after all annotation. Now let's look at an application. We have a custom Java class named data, and it has a method named findLargest. It takes an integer array, and it looks for the largest number in the array and returns that number. So we have a corresponding JUnit test class named dataTest. And in this example, we are reading in a file. This is the file right here, 10, 20, 30, 40. So before we actually call the test method down here, we want to make sure that we read the information into our Java object right here, numbers list. So we use the before all annotation to make sure that that happens first. So the data gets read into this array list, Then we call the test method, test find largest. And then finally, after the test method runs, this after all annotation closes the scanner for us. So let's run this. And we can see that our test method has passed because we were expecting the largest value to be 40, and that is in fact what the method returned for us when we called find largest. In this lesson, we learned how to use the before all and after all annotations. In this lesson, we are going to study the assert array equals method. First, our imports. This import here allows us to use the test annotation, and this import here allows us to use the assert array equals method. In order for assert array equals to pass, the two arrays must be equal in length and must have identical elements. So let's run this. And we can see that this passes because array 1 and array 2 are identical in length and each element is identical. Now let's try to run this one. And we get a fail. This is because array 2 and array 3 have the same length, but at least one of their elements are different from each other. So these two are the same, 1 and 1, but 2 and 7 are different and 3 and 7 are different. So that's why we got the fail. And we can look at the helpful error message. Assertion failed error. Array contents differ at index 1. These are 0 indexed. Expected 2, but was 7. So it tells you the location and the nature of the error, which is very helpful. Now let's try this one. And this assert fails because array 3 and array 4 are different in length. And we can see the helpful error message. Assertion failed error. Array lengths differ. Expected 3, meaning the length, but was 4. Now let's look at an application. We have a custom Java class named GraphQL, and it has two methods, dim and brighten. Dim lowers the pixel values of each RGB by 1 unit, and brighten increases by 1 unit. And we want to make sure that these methods are running properly. Now, importantly, the pixel range for each RGB value is between 0 and 255 inclusive. So if we dim, meaning we lower the value by 1, we want to make sure we don't go below 0. That's why this math.max was in play. And similarly, we don't want to go above 255. That's why the min is in play. So we set up a corresponding JUnit test class named GraphQL_test. Our imports are as before. And let's take a look at the first test method. Here we have a pixel with RGB values 1, 2, 3. We dim it, so we expect that each got lowered by 1, so it became 0, 1, 2. And then when we lower it again, right here with the dim, this initial 0 here, it should not go below 0. So once it hits 0 and you try to lower, it should stay at 0. And then test brighten, this right here, is doing the same sort of test, but for brightening. So we start out at 0, 254, 254. When we brighten, everything gets incremented by 1. So we go 1, 255, 255. And then if we brighten again, these 255s, they should not go any higher. They should just stay where they are. But the 2 should be allowed to brighten. So go from 1 to 2. So let's run this. And we can see that both of our test methods have passed. And we examined the normal case where we didn't hit a boundary, and that passed. And then we tested an edge case where we were up against the value boundary, and that passed as well. And both the normal case and the edge case passed for brighten as well. So that gives us a good confidence that our methods in the GraphQL class are working as expected. In this lesson, we learned how to use the assert array equals method. In this lesson, you are going to get some practice performing a bug fix. First, let's review the bug fix process. You create a JUnit test that triggers the bug. You run the test and get a red bar. This shows that you found the bug. Then you go ahead and fix the source code, and you run your JUnit test again and get a green bar. This shows you fixed the bug. Then you submit your updated source code and the unit test to your tech lead for review merge. So we have a custom JUnit class here named Triangle Utilities. It has two methods, getPerimeter and isIsosceles, and there is an error in the isIsosceles method. An isosceles triangle has two or more sides that are equal in length. So what I want you to do is look at this for a second and try to see what the error is, okay? Then what I want you to do is create a corresponding test method that isolates the error. So take a look at this here, and then write a test that exploits the error. You can do this by actually typing this into your IDE, or you can write it out with pencil and paper, either way. So it turns out that this data right here will exploit the error. Let's run this. And we can see we get a red bar, expected true, but was false. So this is an isosceles triangle because sides A and sides C are equal to each other, but the method is returning false for some reason. The reason it's returning false is because we forgot about that third case. So now that we have fixed the code, we go back and run our test again. And now the test has passed. So that's the process. Before you fix the code, you write the test that triggers the red bar. That shows that you have found the bug. Then you fix your code, and you run the test again and get a green bar, which shows that you have fixed the code. In this lesson, we got practice performing a bug fix. Thank you for taking the time to complete my JUnit Quick Start for Beginners course. In this course, you learned how to use JUnit asserts and annotations to write and run tests. We explored the assert equals method, the assert true method, and many other topics. We saw how to use JUnit to perform bug fixes and feature requests, and we got practice performing a bug fix. I hope you enjoyed the course. Please leave a review, and be sure to check out my full-length course on JUnit 5. Thank you, and good luck in your development efforts.